Section 5.1 Probability Distribution Functions. Let's look at this example. A student takes a 10 questions, true or false, and she tries to guess randomly at each answer. What is the probability of this student passing the quiz with at least 70% correct? And this example isolates one type of probability problems involving discrete random variable. Remember in the session 1.2, we talked about the discrete or continuous random variable. Discrete random variable are the data that are countable. For example, how many siblings do you have? Or how many true or false questions that you got it correct is countable. So we call this as a discrete random variable. Look at the definition. A random variable describes the outcomes of a statistical experiment in words. The values of a random variable can vary with each repetition of an experiment. Random variables are denoted using the letters such as capital letter of X. A random variable is said to be a discrete random variable if it has either a finite or a countable number of values. Random variable notation. If the capital letter X is a random variable, then X is written in words, and lowercase letter of X is given as a number. Example 1. Let X be the number of heads when tossing 3 fair coins. Then the sample space is, can you guys try to write it out? What is the sample space when you flip the coins like 3 times? You can get head, 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 or head, head, tail, or head, tail, head, right? If I write it all out, it gonna be looks like this. And if I use the lowercase letter of X, that represent the number. So since my X represent the number of head, so you can look at here. For this sample space, I don't have any head. So my X is gonna be equal to 0. And this one, I do have a 2 heads. So X is gonna be equal to 2, 2, or X equal to 1 in here because I only have a 1 head. Okay, so my X can be equal to 0, 1, 2, 3. One more time, the capital letter of X is written in words. And then lowercase letter of X, this is represent the number. Definition. Probability distributions provides the possible values of the random variable X and their corresponding probabilities. Probability distribution can be in the form of table, graph, or mathematical formula. So we need to know how to form the probability distribution. And this is the characteristic of a discrete probability distribution. I need you guys remember this 3 requirement. Let P of X denotes the probability that the random variable X equal to the X. Then, probability of X, it has to be in between 0 and 1 for every possible value of X. And then, when you add up all the probability, it has to be equal to 1. And X has to be the numerical outcome. Okay, one more time, this 3 requirement. Once it fulfills this 3 requirement, we're gonna call this is a probability distribution. Okay, look at this example. Which of the following table represent probability distribution? So look at the first one. I do have a 3 requirement. First, each probability has to be in between 0 and 1. So this is good, this is good. This one, probability is going to be less than 0. So I say for the A, this is not a probability distribution because P of 3 is not between 0 and 1. Okay, look at the second one, the B. Each of the probability that is in between 0 and 1, this is good, and X is a numerical outcome. Good. And one more. Try to add up all the P of X to see it's gonna be equal to 1. So we say this is a probability distribution. All the probabilities are between 0 and 1 and they add up to 1. Okay, add it all up, that will be equal to 1 here. I want you guys try to do C, D, and E. Okay, check your work. C, this is not a probability distribution because the probability of this guy is going to be greater than 1, right? P of 0 is not between 0 and 1. D, this is not a probability distribution because when you add it up, the summation of P of X is going to be greater than 1. Okay, last one, E. This is not a probability distribution because the X is not a numerical outcome. Yes, no, don't know. This is not a numerical outcome. Okay, example 3. The table below shows the probability distribution for the random variable X, where X represents the number of movies streamed on Netflix each month. What is probability of streaming at least 3 movies each month? And what is probability of streaming less than 3 movies each month? Okay, so let's double check. Even though they've given this as a probability distribution, I just want to check with you guys here. So each probability between 0 and 1, add it all up, that will be equal to 1. X is a numerical outcome. So this is good, right? Now, we're on the first question. What is probability of streaming at least 3 movies each month? So we are looking for at least 3. So at least 3 means X has to be greater than or equal to 3. Look at X greater than or equal to 3. So that will be these 3 guys here. So let's try to add it up these 3. So P of 3 plus P of 4 plus P of 5. And that would be 0.14. Okay, next one. What is probability of streaming less than 3 movies each month? Less than 3. So less than 3, that's not including the 3, right? So that will be these 3 guys. Add it up. You're gonna get 0.86. When evaluating the long-term results of statistical experiments, we often want to know the average outcome. The long-term average is known as the mean or expected value of the experiment. So for the probability distribution, we need to know how to find the mean. And then in the probability distribution, the mean also called expected value. So we need to know how to compute and interpret the mean for the discrete random variable. First, the notation. Probability distribution, we're gonna put mu of X in here. And then summation of the X times of P of X. And then add it all up together. And X will be the value of the random variable. P of X will be the probability of observing the value X. I need you guys know how to work on it using the formula, and also you need to know how to work on it using your calculator. So let's look at the example 4. The table below shows the probability distribution for the random variable x, where x represents the number of movies streamed on Netflix each month. Compute the mean of the probability distribution. Interpret the mean of the probability distribution. Okay, so this is gonna be the probability distribution. Let's write down the formula. Make sure you including the notation, okay, mu of x in here. Then we're gonna do it one by one. The x represent the 0 here. 0 times 0.06 plus 1 times 0.58 plus 2 times 0.22. Okay, and then add it all up. So you should have the word like this. Use your calculator. You're gonna get 1.49. Now, we need to know how to interpret the mean of probability distribution. We're gonna say, in the long term, we can expect an average number of movies streamed per month to be 1.49 movie. Okay, mean you can think about the average number. Interpret the mean of a discrete random variable has an expected value. Okay, so why the mean will be equal to the expected value? Expected value is perhaps the most useful probability concept we will discuss. It has many applications, from insurance policy to making financial decisions. It is one thing that casinos and government agencies that run gambling operations and lotteries hope most people never discover. So definition, expected value is the average gain or loss of an event, given the procedure is repeated many times. An expected value is obtained by taking the sum of the products of each outcome and the probability of that outcome. If the expected value of a game is 0, it is called fair game, where neither side has an advantage. Okay, so in the casino, we could try to calculate the expected value of that game. If you find it out that's equal to 0, means the game is fair. Example 5. In the game of roulette, a player can place a $5 bet on the number 17 and have a 1 over 38 probability of winning. If the metal balls lands on 17, the players wins 175. Otherwise, the casino take the player's $5. Create a table showing the probability distribution for the amount of money you win playing this game. What is the expected value of game to the player? If you play the game 1,000 times, how much would you expect to lose? Okay, so let's write it out. First, I'm gonna let probability of W, means like the winning, okay? Probability of winning, that will be equal to 1 over 38. So that will be on this probability. And then probability that I'm gonna lose the game, that will be 1 minus the winning. Okay, so win or lose, that will be the complement. And then we're gonna plug it in. You're gonna get 37 over 38. The net gain when winning is calculated has the payout minus the bet. So either you can win $175 or you may lose your $5. So the net gain will be 175 minus $5, which is going to be 170. Now, we try to create the probability distribution. And think about it. I could win the money like $170. And the probability of winning, that will be 1 over 38 here. If I lose, I will lose like $5. And I'm gonna put the negative here. Okay, negative means I lose the money. And the probability, that will be 37 over 38. Now let's try to find the expected value. It means the mean, right? So we're gonna apply the formula. 170 times the probability plus negative 5 times probability. You're gonna get negative 0.39 cents. Remember we say if you find the expected value equal to 0, then this is a fair game. So obviously this is not a fair game. After we find the expected value, they're gonna say if you pay the game 1,000 times, how much would you expect to lose? So we're gonna use the expected value times 1,000 times, which is gonna be 390. Example 6. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. This policy have premiums that must be paid annually. Suppose a life insurance company sell a $250,000 one-year term life insurance policy to a 49-year-old female for $530. According to the National Vital Statistic Report, the probability the female will survive the year is 0.99791. Compute the expected value of this policy to the insurance company and interpret the expected value. For the insurance company, a one-year term life insurance policy, they do have the two possible outcomes. For the first one, if the female survive on that year, the probability that she's gonna survive will be equal to this number. If the female survive on that year, the company keeps the premium and pays nothing. So for the insurance company, they only have the profit for $530. For the outcome 2, if the female dies within that year, first we need to calculate what is the probability she die. So think about it. Survive and die will be the complement. We could just subtract from 1 here. So probability that the females die will be equal to 0.00209. And if the females die within that year, the company must pay the death benefit $250,000. But the insurance company still received the $530 premium. So the profit that will be equal to 250,000 minus 530. Now we try to form the probability distribution for insurance company profit. First, when the insurance company only receives the annual premium $530, the probability that the females will survive will be equal to this guy. If the females dies, then the insurance company need to pay on this amount. So that will be a negative numbers in here. And the amount will be negative because like when insurance has the profit, that will be 530. But if the females die, then the insurance gonna give out this money. So that will be the negative. And the probability for this amount will be equal to this guy, 0.00209. Now we're gonna compute the expected value. We're gonna apply the formula. X times the P of X plus X times of P of X. Use your calculator. You're gonna get this number. 750. Now let's try to interpret the expected value. On average, the insurance company expects to make about $7.50 profit for each 1 year 250,000 policy. It sells to a 49 years old female. However, this does not mean the company earns 750 cents on this specific customer. Rather, most year the company earns $530 per policy, and very lower chance that the company will lose $249,470. Compute the standard deviation of a discrete random variable. We call the standard deviation represent the average distance from the mean or average. The variance is the square of the standard deviation. So from the previous slide, we just learned how to find the mean for the probability distribution. Now let's look at the standard deviation. We have the formula for the standard deviation of a discrete random variable. You need to find out the mean first, okay? And then x squared times p of x, add it all up, and then at the end, you're gonna subtract the mean square. Variance, you're gonna take square of the standard deviation. And this is the step how you guys use the TI-84 calculator to find out the mean and also the standard deviation for the discrete random variable. Example 7. Let's try on this example with the mean and the standard deviation. And then we work on this example on example 4 already. We use the formula find out the mean. Okay, so you know the mean is going to be equal to 1.49. Now, let's try to work on the standard deviation. We have this formula. So plug it in one by one. Take square of the x times of the px plus 1 square times 0.58. Okay, keep going for all of it. And then at the end, you're going to subtract mean square here. Use your calculator. You should get 0.93. Okay, so this is going to be the standard deviation. So if you want to find the variance, you're going to take square of this guy. So that will be 0.87. Now, let's interpret the standard deviation. The average number of movies seen is 1.5 movies, give or take 0.93 movie. 1.5, that is talking about your mean here. 0.93, that will be the standard deviation. Okay, now let's try to use your calculator. So, click on the stat. Number 1, for the L1, I'm gonna plug in the x here. And then L2, I'm gonna plug in the probability. Okay, double check. Okay, then click on the stat. Click on the cal. Click on number 1, one variable statistic. And then my data is gonna be on L1. So second 1 for L1. Frequency, I'm gonna put the L2. Second 2 for the L2 and then go to calculate. So you're gonna find out the mean, that will be 1.49. And then standard deviation, that will be 0.93. 0.93 here. Variance, that will be take square of the standard deviation. That's it.